Welcome to the February-March 2023 core paper 12. I'm going to show you how to use trigonometry, when to use Pythagoras, when to use SOHCAHTOA, and there's lots of pies involved as well. Okay, join me and I'll show you all the answers. Question 1. 25, let's put that, 25 million. Million has got 6 zeros. So that's it, 25 million. 0.7 as a fraction. Now remember, these are the tenths. We start with the tenths. So that will be 7 out of 10. 13 out of 20 as a percentage. Now remember, percentage, percientos, simply means how much is it out of 100. So how are we going to change that 20 to 100? Well, we need to times it by 5, is it not? So we times the top by 5. 13 times 5, of course, is 65. So that would be 65%, because 65 out of 100 means exactly the same. Yeah? So you got 2a, you got some equivalent fractions. You got 14 over 20, 70 over 100. All right, we've got a list of numbers in question 3. And from the list of numbers, find all the numbers which are less than minus 5. Think it of as a temperature, yeah? Less than minus 5, colder than minus 5. Anything that sounds bigger but is smaller, minus 7, minus 6, minus 8. All the numbers, we need to write all of them. Let's write them from the biggest to the smallest, yeah? Yep, I guess you have to have all 3 to get that right. The product of the largest number and the smallest number. Now remember, product means multiply. So the largest number there, of course, would be 15. Smallest number is going to be negative, and the lowest down is minus 8. So don't waste your time here. 15 times negative 8. There we go, minus 120. It's 1 mark only, so just minus 120 will do the trick. Exam start at 10 to 12 and lasts for 2 hours and a quarter. 2¼ hours. Work out the time the exam finishes. What does a quarter of an hour look like? Of course, that's 15 minutes. All right. So what we're looking here is 2 hours, 15 minutes. Now I like to do the leapfrog method. So we start at 11:50. Now first we're going to jump 10 minutes to 12 o'clock. Okay. So you see this 15 minutes? We've already done 10 of those. So we do jump another 5. But I'm going to jump minutes now, I'm going to jump hours. So we want to jump 2 hours from 12. That will be 1400 hours, 2 o'clock in the afternoon. Okay, so that's 2 hours, 10 minutes. And we're going to have to jump another 5 minutes to finish up that quarter of an hour. And that's it. 14:05. If you write a 24-hour clock, they don't say. I guess if you write 2:05 p.m., it's also correct. But let's have a look. Oh, no, they just put 14:05 there. So I don't know about that 2:05 p.m. I have no idea. I think it should be right, but keep a 24-hour clock. I guess because this isn't the 24-hour clock, we keep it 24-hour clock. It's now a.m. p.m. Okay. Correct. Next, we go around this 56.17345. 1 decimal place, which is there. That 1 is in the first decimal place position. So we need to cut it off there. But there's a 7. When it's a 7, we need to round it up to 56.2. Yep, 56.2. Work out the number of seconds in 5 hours. Oh, goodness. Let's start. First, work out the number of minutes in 5 hours. 5 hours, each hour's got 60 minutes. 5 times 6 is 30, add the 0, so that's 300 hours. Each hour it got 60, it's not 300 hours, it's 5 hours, can't be 300 hours, 300 minutes, stupid. Okay, so each minute has got 60 seconds, so we need to take that 300 minutes and times it by 60. 3 times 6 being 18, and then we add 3 zeros. 18,000 seconds. Okay, you got the S there, so we just need to put 18,000 on the line. Okay. Yeah, you do get a method mark, so multiplying by 60 twice. So these two together. Okay, these two together gives you 1 mark there. Up to question 7. The cube number. What's a cube number? Okay. Cube numbers, of course, is 1 cubed, which is 1. 2 cubed, which is 8. There's a 1 or 8. No. 3 cubed, which is 3. Times 3, which is 9. Times 3, which is 27. And there we go. That's the cube number 27, which is 3 times 3 times 3. Where we are? Right down there. Okay, that's the only correct answer. Prime number is a number that can only be divided by 1 and the number itself. So, for example, 12 will not be a prime number because we can divide it by 1 and we can divide it by 12, but we also can divide it by 3, by 4, oh, we forgot about 2 and 6, so that's got a lot of factors. We only need 2 factors. 15 has got 1, 3, 5, 15, so not a prime number. 27, loads. What about 29? What can we divide into 29? Other than 1 and 29. Think of anything? I can't think of anything, so it must be a prime number. Okay, 93 is not a prime number because we can divide it by 3. We can divide 9 by 3 and 3, so 93 divided by 3 will be 31. So those are 2 factors, 3 and 31. 91 though, let me see, is 91 a prime number? Turns out, no, it's not a prime number because 29 was the only correct answer. Well, what can we divide into 29? Think about that one. What can we do? I mean, a 91. It's not 3, 4, 5, 6, 7. 91 divided by 7. 13, bam, see? So 91 has got factors 7 and 13. That's why it's not a prime number. Be careful with these things. 29, only correct answer. Right, here we got column vector. It describes the movement of an object. The top number tells you left or right, negative. So V, for example, will be a vector that starts there and it goes 1 square to the left. That's the minus 1. Yeah, that one over there, and it goes 3 squares up. So that will be the vector V. The vector Y, on the other hand, will go 2 squares to the right and then 5 squares up. That's not relevant anyway, because subtracting them is pretty easy. You just take vector V, minus 1 and 3, and you subtract from that vector Y, which is 2 and 5. Make sure your 5s looks pretty. I really have a problem making 5s. Okay, so at the top we got minus 1, minus 2. Minus 1, minus 2, of course, is minus 3. And 3 minus 5 is, of course, minus 2. Okay, that will be the vector here. Minus 3 and minus 2 when you subtract them. Really ugly diagram there I drew in, but they don't even make it harder than this, so just subtract them. 2V, put the 2 and then you put vector V. then you multiply the 2 with a minus 1, that gives you minus 2. You multiply the 2 with a 3, that gives you 6. Basically, if the vector v is 1 squared to the left, 3 squares up, you got to put a 2 in front, you double that. So the vector v is now twice. Interesting, isn't it? Yeah, anyway, those are the correct answers. You don't believe me? There they are. Minus 3, minus 2, minus 2, minus 6. Right, rupees. 6,500 of them buys you a suitcase. Calculate the cost. Oh, suit. It's not a suitcase. Suit. Tie. Suit. Calculate the cost of the suit in dollars when the exchange rate is 1 rupee. Yes, it's only $0.013, 1.3 cents for 1 rupee. Interesting. Okay, so let's do it. Let's do this. Okay. So we got the rupees indicated by an R, and we got the dollars indicated by dollars. So 1 rupee is 0.013. So we want to know what is 6,500 rupees. You see, my ratio has been multiplied by 6,500. So we're going to do the same here. We just simply multiply 0.013 times 6,500. $84, $84.50. Can you buy a nice suit for $84.50? I don't know, you tell me. I'm not buying lots of suits lately. But yeah, that's correct. 0 is optional. Right, question 10 here. Got a little conundrum. We draw the net of a cuboid. Now remember, cuboid got 6 faces. Right? A box here. Alright. Box, cuboid, got 6 faces. Right. So we need to draw 6 rectangles on this page here. Problem is we don't have the actual dimensions. We only got the volume of a cuboid. So let me just make a 3D sketch down here, right? And use a pencil. So let's say this is the base of a cuboid. So that will be 4 centimeters long and 3 centimeters wide. So just roughly here. Okay. Base of a cuboid. Okay, what we want to do now, so that's 4 and 3. If we want to know what the rest of the cuboid looks like, you know, we want to actually know how high is that cuboid. Because if we do the length times the width times the height, we get the volume, which they gave us is 24 centimeters cubed. So we know already the length is 4 and the width is 3. So what do we need to multiply that by to get 24? 4 times 3 being 12 must be 2. So the height is 2. Okay. So we already have, let's change color. We already have the base there of the cuboid drawn on the page. We now need to draw the other sides attached to it. And if you look here, on the right hand there's a cuboid attached, which is 2 by 3, and on the other side will be the same. So we need to do that. We need to draw a cuboid on the right using a ruler. Like this. Oh my goodness, there must be a better way. I need a better program here. Okay, you see that will be the right face. Oh man, that's ugly. Okay, and over here, that's better. It's ugly. I'm struggling, am I not, to make this look decent? So we got the base of the cuboid and we got the 2 sides. We now want the front and the back. Okay. So the front, change color again, is here. That's the front. You see, this is the front face. The cuboid here. And that is 4 and 2. Again, so it's 2 again. So we already have the 4, we just need to add the 2. Okay. Like this. And again, so ugly. Why does it come out so ugly? Man, I hope when you do your exam, you can make things look pretty. I'm struggling, especially with it. Which makes sense, because if you're going to fold this, yeah, this 2 and that 2 would come together to form an edge. Okay, so that, I would say that was the back of my cuboid. Let me draw some lines here. Okay. So that's the front and the back. So we've got the base, we've got the left, the right, we've got the front, the back. Now just the top. And the top, of course, is the same as the bottom. Yeah? If we look here, there's the top, which of course would be the same as the bottom. So we just need to draw another rectangle. That's 3 by 4. So ugly. And that's it. Remember, 6 faces. Always, you got 2. That's the same. The 2 sides are the same. The top and the bottom are the same. The front and the back is the same. Yeah, that's it. Fully correct net. Doesn't really tell you here what it looks like, but I've shown you. Just do it a bit prettier than me, please. Okay. Question 11. The median of 6 numbers. What is median again? Huh? You need to study these things. Mode, median, mean, and range. Mode, the most. Mean, the mean one, because you have to add everything up, and that's the most work. Median being the middle. Okay. So there are 6 numbers, and 5 of the numbers is given to us. Now 61 needs to be in the middle. Yeah? So they say it's 24. Median, always put the numbers from the smallest to the biggest. And then the 6th number is the one we don't know. Okay, so you see there's 6 numbers. 24, 43, 58, 7, 85. And the middle, where it's going to be the middle of the 6 numbers, is going to be between 2 numbers. That must be the middle, because we've got 3 on the left, 3 on the right. And that is 61. Interesting. This doesn't make sense. Because if 58 was the 3rd number and 71 the 4th number, then 61 has to be halfway between 58 and 61. But it's not. As you can see, the gap between 61 and 58 is 3. And the gap between 61 and 71 is 10. Something is wrong here. Do you understand what's going on? Let me give you another example. Let's say we got 4 numbers. Let's say the 4 numbers was 3, 5, 9, and 12. Now the middle will be between 5 and 9. What's halfway between 5 and 9? Well, we want to know that. We do 5 plus 9 is 14 divided by 2 is 7. So the middle there will be 7. If you subtract 2 from 7, you get 5. You add 2, you get 9. 7 is halfway. But 61 is not halfway between. Okay. So, I think they're kerfuffling us here. Okay. It means the 6th number is not the last number. Right? The 6th number must be the 4th number. So we're going to shift everything up. Okay, so we make 85 and 71. Okay, that means 58 to 61 is a gap of 3. Add 3 to 61, that gives us 64. See, now we got 1, 2, 3, 4, 5, 6 numbers. The middle is between the third and the fourth number. The median is 61 because it's halfway between 58 and 64. So the answer here would be 64. They only give you 1 mark for all that thinking. I'm right though. I hope you understood that. Okay, the size of one interior angle of a regular 9-sided polygon. And here you need to remember the formula for the interior angles of any polygons. Okay, if you forget the formula, remember this. A triangle adds up to 180 degrees. Triangle has got 3 sides. A square or a rectangle, which is 2 triangles, it's got 4 sides, adds up to 360, or 2 times 180. Why? Because there's 2 triangles. A pentagon, which has got 5 sides, adds up to 540 because it's 3 times 180. Because there's 1, 2, 3 triangles that fit into the polygon, and that continues like that. Okay, so a 9-sided shape, how many triangles is going to fit inside? Well, the answer lies here. Right, a 4-sided shape has 2 triangles. A 5-sided shape has got 3 triangles. The number of triangles is always 2 less than the number of sides. So a 9-sided shape, well, that's why the formula is n minus 2 times 180. So a 9-sided shape will fit inside 7 triangles, so you need to do 7 times 180. So always the number of sides minus 2 times 180. So we do just 7 times 180. 1,260. That's what all the angles in a 9-sided polygon. What's a 9-sided polygon? Nonagon? Yeah, nonagon. Add up to. Okay, good thing that this is a regular polygon. Regular means all the angles exactly the same side. We know there's exactly 9 angles. We know they all add up to 1,260. No comment. So we know we need to divide it by 9. So you do 1,260 divided by 9. 140 degrees. That is the size of one angle. Okay, I'm correct. As you can see, you get working out. Well, there's another method. The one where you work the exterior angles. And this is the method here that I did. Okay, so you get 1 mark for the method. Yeah, method here, and 1 mark for the answer. Question 13. Oh, Venn. My good old friend Venn. On this Venn diagram, shade the region A intersect B. Remember now, Venn diagrams, we've got 2 things. We've got the intersection. And we got the union. Union is the nice one because union accepts everybody. It's just union. If it was A union B, we take all of A, we take all of B, and we have them all, right? Intersection is more like this has to be an A, has to be an B. Okay, you understand what I'm saying? Well, let me show what I'm saying. A intersection B is only that. Has to be an A, has to be an B. Simple as that. Union would have meant that we also shade this part and that part, okay, but looks like an alien. I'm not going to confuse you, that is the answer. There you see. Okay, don't shade it like that though, shade it like I did, nice and pretty. Okay. Question 14, factorization. Okay, I like to break things down. You can break 8 into its 2 factors. 8 is 2 times 4 times g. I'm going to 2, and then g squared means g times g. So then we check, all right, what do they have in common? Well, they both have a 2, and they both have a g. So we're going to take that 2 and the g, we put it in the front of the bracket. And then we take what's left. Okay, there's a minus. Don't forget there's a minus. We keep the minus there. There's left a 4 here. And there's left a g there. And it's done. 2g times 4 is 8g. 2g times minus g gives you minus 2g squared. Final answer. Okay, you get 1 mark if you do partial factorization. If you only take the 2 out or only the g out. Question 15, good old circle theorems. It's always helpful to read through the instructions carefully. The diagram shows a circle. Bam, I can see that. Okay, but they say it because circles have certain specific characteristics. So that's why I focus your attention to it. It's important that they tell you that is the middle, because if they don't tell you it's the middle, then it's not the middle. Okay. Don't assume it's the middle, but now it's the middle, so we're going to keep it as the middle. We know it's the middle. The middle is important because the middle gets connected to the circumference by a radii, and a radii is always the same length. Okay, so that already tells us that this line here, and this line here, and this line here, and this line there, they're all the same length. This might be one of the most important things to remember. The radius is always the same length. The radius connects the center to the circumference. The moment, if you're stuck with these questions, just look for the radius. Okay. Diameter AC. It just tells us from A to C is the diameter because it goes through the center. Yeah. Okay. And A, B, C, D, and E is on the circumference of the circle. Find the value of x. Find the value of y. I'm going to start with y because that's the easiest one. You see already I've marked these 2 lines. What does that mean? Isosceles triangle. Isosceles triangle is got 2 sides the same length, and we got 2 sides the same length. That means the 2 base angles is the same. So y is the same as the other angle over there, 46. So y is 46. And it's because ODE, you see how it's ODE, describes that triangle, is an isosceles, how you spell it? Triangle. We would have been better, say base angles of an isosceles triangle, right? I'm just going to add it in. Base angles are equal. Something like that. That's the most thorough answer I can think of at this moment. We'll get back to that. Let's do A. Alright, so X is there in a triangle. What do you know about triangles? You know triangles equals 180 degrees. But we don't have this angle there. Or do we? Do we have it? Do we? Yes, we do. Okay, remember this circle theorem, that if you've got a diameter which goes through the center, because they told us that, right, then the angle on the circumference it forms is 90 degrees. So we know that that is 90 degrees. So we want to know what's x. We just need to subtract from 180, because that's all the angles in the triangle, the 90 and the 65. What is that? 90, 100 is 90, 65 is 25. 25 degrees. I mean, use your calculator if you're not sure. So what did we use? We used this theorem here, and it's called angle in a semicircle. Equals 90 degrees. Well, I only used angles in a triangle. So I'm going to add it. I don't know. Let's see what the math scheme says, right? Because I've written a lot of stuff, and let's see what's really important. My red pen. Yeah, okay. 25, got it right. Angle in a semicircle is 90. So if it was a real exam, 1 mark there. Angle is semi. I've got it exactly right, huh? Must have done this before. 46 base angles of an isosceles triangle are equal. 46 isosceles triangles, base angles are equal. So I wrote it a bit the wrong way around, made it a bit long. So there's a shorter way. Base angles of an isosceles triangles are equal. That will be good enough. Okay. This little bit of practice and you'll get this right every time. Without using your calculator, work out 4, 7 divided by 8. Yeah, I got the answer, 1/14. Okay. 1/14. Okay, what did I do? I used my calculator. Did anybody check? No. Easy marks. No, because this is, I wrote the right answer on the line. You're going to still get 0 marks. Okay, you need to show how to get this without a calculator. And how do you get it? Well, first, I'm going to remember that 8 is the same as 8 over 1. Okay, because 8 divided by 1 is 8. So that's a fraction. And when you divide with fractions, the trick is invert and multiply. So you swap around the second fraction. The first one stays the same. 4 over 7 stays for 7. And multiply. Now it's easy. Multiplying fractions is easy as pie. 4 times 1 is 4. 7 times 8 was 56. Yeah, divide top and bottom by 4 and we get 1 over 14. Now I get full marks. Okay, let's see what they want to see. Okay, so there's this method here, but I've never seen anybody use it. Okay, you see that? 4 over 7 times 1 over 8 and then answer, correct answer only. So yeah, pretty much 1 mark there, and then they say fine. We assume you don't use a calculator to give you a mark for that one, but you don't get the mark for 1 over 14. Don't show you're working out. Okay, so you can use your calculator to check, but you need to show every step. Right, the school records how many calculators it sells each week for 40 weeks. You understand that? So for 14 weeks, they didn't sell any calculator. It was 12 weeks they sold 1 calculator. 1 week they sold 6 calculators. That was the one just before the exam. So we I need a calculator. Okay. They never sold 4 calculators in a week. Okay. Work out the mean number of calculator school sells each week. Mean. Remember, we have to add it all up. We have to add up all the calculators that was sold. Okay, how many calculators did they sell? 40? No, they were selling them for 40 weeks. You'll see the frequency adds up to 40. But if we want to know how many calculators they sold, we need to multiply the number of calculators with the frequency. Does it make sense? Let me show you the full correct working out. So, there were 14 weeks they didn't sell any calculators. So how many calculators did they sell those 14 weeks? 0. I can actually leave that part out. Then we're going to add those 0 calculators to the 12 weeks, they sold 1. So those are 12 calculators. To that we're going to add the 6 weeks they sold 2 calculators, so that's also 12 calculators. So we've got 24 now. Then they sold 5 weeks 3 calculators, so we add another 15. Then they sold 4 calculators in 0 weeks. Again, that's 0 calculators. We could have left that out. 2 weeks they sold 5 calculators. There's another 10 calculators sold. And then there was that 1 week they sold 6 calculators. That's another 6. Okay. So it's not as hard as it looks. Okay. 12 plus 12 is 24. Plus 15 is 39. Plus 10 is 49. 55. They sold 55 calculators. Yeah, so we double check. 12. This 12, of course. There's another 12. There's another 15. This is 0 and 0, so I'll leave that out. 10 and 6. Always good to double check, yeah. It's 12 plus 12 plus 15 plus 10 plus 6. 55 calculators sold. Okay? That's the total calculators sold. We want to know how many per week. How many weeks did they tell them to sell that? 40. Divide that by 40. So 55 divided by 40. 1.375. Now, yes, they don't sell 0.375 of a calculator. They don't break it apart and give you that. But this is how mean works, okay? Do we round it? No, because this is an exact answer. Only if those decimals were going on forever do you round it. Final answer, 1.375. Yep, that's correct. Don't round it. You see, there's my working out. Just like I've shown. You get a mark for 40. Basically, show your working out because you get a mark for this, get a mark for dividing by 40, and then a mark for the answer. Show your working out. Question 18. Somebody's got a bag of sand. Nice. And it's 12 kilograms, but not exactly. The answer has been rounded. It could be a little bit more than 12, could be a little less than 12, okay? It's been rounded to the nearest kilogram, which we could say is the nearest 1 kilogram. Now the little trick here, if you get confused, is just take that 1 kilogram divided by 2, that will give you half a kilogram. These is bounds. You want to get the lower bound. You take 12 minus 0.5, that gives you 11.5 kilograms. That means the bag might actually only weigh 11.5, and then round it up to 12. Okay. If you want to have the upper bound, you add 0.5, and that is 12.5. Yeah, now 12.5 does not round to 12. Okay. So actually the bag could have been 12.49 recurring kilograms, but you see this sign here, it means less than, not equal, so anything less than 12.5, that's why we put 12.5. Okay, so that means the bag is anywhere between 11.5 and 12.5, 11.5 included, 12.5 not. Okay, and that's what you need to write. Don't write 12.49 recurring, okay? If they wanted you to write that, then they would have put it this sign. Then you write 12.49 recurring, you got that sign. But we don't. Okay, pretty clear. Kiana, interesting name, invests $3,000, she's smart, or he, I don't know, at a rate of 4% compound interest. Calculate the value for investment at the end of 6 years. Now there's a long way to do it, and there's the formula, right? The formula for compound interest, of course, is the amount equals P, which is principal, which is the original amount that you put in, 1 plus R, which is the rate, over 100 to the power of T, which of course is the time. So to get the amount, which is the value of our investment, we do 3001 plus the rate is 4 over 100 to the power of 6. Yeah, that's the shortest way to do this. And let's do it. Nice. Look at the buttons I push. 3795.957. Okay, now how are you going to round this? Are you going to round it? What are you going to do? 3 significant figures? Well, it's money, so I like to round it to 3795 point. You see there's a 7, so that 5 becomes a 6. But I think because we're rounding everything to 3 significant figures, you can also do cut it off there, 3800. That would be 3 significant figures, because after 79 comes 80, even though it looks like 2 significant figures. Mark scheme, rounded to 3 significant figures, which looks like 2 significant figures, but it is 3. Or 3 standard, or, you know, they accept all the answers. They're all happy with it. You see, there's the formula. Okay. So don't beat your head over this. 1 mark for showing that formula, and 1 mark for writing the answer very clearly, rounded, unrounded. Okay, I think the most accurate is those, though, because they say 3 figures. But you get marks for the other ones. Anyway. Question 20. Solve. All right. You see that 25 minus 2u, it's always being divided by 3. So we just throw the 3 to the other side, opposite sides, change sides, change sign. Divide becomes times. Anyway, so that gives us 25 minus 2u equals 6. What shall we do next? Well, I'm going to subtract 6 from both sides, which gives us 25 minus 6. And I'm going to add 2u to both sides. Basically, I've moved the 2u there, negative becomes positive, and I moved the 6 there, positive becomes negative. That gives us 19 equals 2u, and then we divide everything by 2. Half of 19, of course, is 9.5. I got another method there. Oh, see, the first method was my method. Okay, they got another method, so interesting, huh? You already got a mark for just doing that, and a mark for the answer. Calculate 0.3 squared. Easy, easy. 0.3 squared. There we go. Let's put that 0.09. Oh, no, I don't want to write in red. Full marks? No, because now they want it in standard form. Remember standard form, you write a number, and that number is from 1 to 9, like 5.3, times 10 to the power of something. Okay, so it means the first number there needs to be bigger, so we move the decimal point twice to over there, so it becomes 9 times 10 to the power of small number. We move the 2 spaces, that's minus 2. Don't believe me? Put this into your calculator. What's that called? Okay, so put 9, use this button, negative 2. See? Same thing. Or even better, press Shift, set up. We want it in psi, which is scientific notation. You press 7. Then you pick a number between 0 and 9. Okay. Just like do 3, because we do 3 significant figures. And you press equal. And there it goes, you standard form. because I press 3, you put 0.00. Okay, so then your calculator gives you anything you type in standard form. Ground it to 3 significant figures. Change it back, press shift, set up, we want norm for normal, and then press 1 or 2, press 2 just because I say so. And you're back to being normal. Okay, so final answer, 9 times 10 to the power of minus 2. There we go. Okay. Okay, the probability of passing a driving test is 0.36. That's 36%. That is not very high. 600 people take this driving test. So all you need to do is multiply those two numbers together. Yeah. You multiply probability by a number, you get the number. 216 people is expected to pass. It's so difficult. That's it. 216. Solve the simultaneous equation. Now look what they've done, right? They've already lined up the equal signs nicely, the numbers, the y's, the x's, everything is lined up. That means this is ready for the elimination method. Elimination method, we add or subtract the two equations together. So we subtract this or we add this. Okay. Only problem is now if you're going to add this, we'll get 4x and 2y plus y is minus y. I haven't eliminated anything. Elimination method wants you to get rid of an x or a y. So adding is not going to work. Subtracting 3x minus x gives you 2x, minus 2y minus y gives you minus 3y. See, that's not going to work either because we haven't eliminated anything. So what we need to do is we need to get in front of the x, the coefficient there or there, the same. So we need to put a 3 in front of the x or a 2 in front of the y. Okay. What I'm going to do is I'm going to put a 2 in front of the y there. Okay, you can put a 3 in front of the x, so there's more than one method. And we do that, because we can't just put it there, because then we change the equation. We do that by multiplying the whole equation by 2. Yeah, so this equation becomes 2x plus 2y equals 6. Alright, this equation is still true because we multiply everything by 2. Okay, now I'm just going to write the first equation again, which is 3x minus 2y equals 19. Okay, now you see we got 2y and 2y. Next step is to add or subtract. Let's put another color in here. Okay, so what's going to work? Well, if we subtract, we get 3x minus 2x is fine, and minus 2y minus plus 2y. What's a plus and a minus? It's a minus. So that will give us minus 4y. So subtracting is not going to work. Let's see what happens if we add. Okay, so if we add, we get 3x plus 2x is 5x. That's still fine. And then we got minus 2y plus 2y. 2 pluses is a plus. Minus 2y plus 2y will give us 0. And that's exactly what we're going for. We eliminated the y's. They are gone. So we can just leave it blank there. And 19 plus 6 is 25. So that gives us 5x is 25. So x, let's divide everything by 5. X is 5. Nice, isn't it? Okay. Oh, but we still need the y. Why? Because we need both. Right, so let's change colors. Put in orange. Okay, so how do we get y? Well, we just check any equation here. I'm going to take this one. This has got the least number. So we got x plus y equals 3. We know x is 5. So what do I add to 5 to get 3? Well, just subtract the 5 on the other side. Minus 2. 5 plus minus 2 is 3. Done. Alright, you don't have to do this. You got some time to do it. Check if your answer is right. Let's take the equation we haven't used. The 3x minus 2y equals 19. Put our answers in there. So we know that x is 5 and y is minus 2. 3 times 5 is 15. Minus 2 times minus 2 is positive 4. 15 plus 4 is 19. Does 19 equal 19? Of course it does. So we know we got the right answer. Okay, just like the mark scheme will tell us. 5 and minus 2. Okay. You get a mark here for eliminating the y. We could have done the x, and then a mark for each correct answer. Right, like I said, you could have eliminated the x's first. Too lazy to do both. Okay, oh, 24. A triangle. Triangles, of course, is trigonometry. Right, trigonometry and the right angles is only one of two things. We use Pythagoras. Pythagoras is, if we're going to right angle triangle, we only work with the lengths of the sides. So you want to work out one length, you got the other two lengths, you use Pythagoras. Okay, and then also the moment we involve an angle and some of the sides, you want to know the angle, you want to use the angle, that's when we do SOHCAHTOA. Right, so in this question, all right, we got two side lengths, but they want us to work out an angle, so only SOHCAHTOA will suffice. And they actually give us the angle. They don't give us the answer, we just need to show how. So first thing we need to do is, of course, label the sides. The side opposite the 90-degree angle is always the hypotenuse. The angle opposite, the side opposite the angle we want, that's of course the opposite side. And then right next to the angle, that's the adjacent. Yeah, next to you. Right, adjacent. So, what do we do next? Well, we check what we're using. We're using the opposite and the adjacent to work out that angle. So it's O and A. O and A is toa. So we're going to use toa. Toa. Toa, the T stands for ton. Then we always put the angle, which we're not supposed to know yet, we need to show it. So the angle in this case, we're going to keep it as Y. Then we got the opposite, which is 46. That always goes on the top. So the first thing goes on the top, 46 over the adjacent 74. That's the ratio. So how are we going to work out Y? We need to move the ton to the other side. Alright, but change sides, change sign, change plus becomes a minus, and times becomes a divide. What does ton do? Becomes the power of minus 1. Okay, so the next step would be to get the calculator out and then press shift, ton, okay, and then we got 46 over 74, close bracket, bam, 31.8659, etc. Correct to one decimal place. So we write the big long answer and then we show if you round it. Squiggly equal sign, it will be 31 point, cut it off there, there's a 6, that becomes a 9. Okay, that is a perfect written answer. Write it like that to get full marks. Okay, you see here, this is very important. You need to write down the unrounded answer to show that it rounds to one decimal place. So if I have to be specific here, get a mark for writing the ton ratio correctly. You get a mark for writing the unrounded answer. You see that? They don't want 31.9 there. So you can leave that out. because they already told you 31.9. They want to see the unrounded answer. That's important. Keep that in mind. Right. Ooh, more triangles. Okay, so remember what we said here before. Trigonometry is Pythagoras SOHCAHTOA. Pythagoras is when we only work with the side length. So if you look here, in question 25, there's only side lengths. Yes, there's a 90-degree angles are there to show us that we work in right-angle triangles. It means we can use Pythagoras, but from there, we're only going to use the side lengths. Okay, so if we look at triangle, I don't like this. This doesn't work. Okay, if we look at triangle ABCD, we don't have enough information. We only got one side. Okay, so we're going to start the triangle where we have more information. That's the one ABC. That one there. Alright, we got two sides, and we can work out a third side, and that third side, of course, is the hypotenuse. Okay, so what is the Pythagoras theorem? Well, it's the hypotenuse, which in this case is AC, square it, equals the other two sides, that will be AB, 39 squared, plus BC squared, yeah? So that means AC squared will be AB, which is 39 squared, plus BC, which is 52 squared. Okay, now before I go to my calculator, I want to do one more thing. I don't want to know what's AC squared. I want to know what's AC. So that square, we move it to the other side, becomes square root. I like to do it like this because now we can put all of it into our calculator at once. Because if you work out something, write it down, and use the again. You make mistakes. Put it all at once. 39 squared plus 52 squared. Square root. Make sure that line extends over everything. 65 we got. So now we know the hypotenuse here is 65. Okay. Now we can use this triangle ACD, because we got 65 and 25. Okay. So what is the Pythagoras theorem for this one? Well, again, the hypotenuse still is AC squared for that triangle. Will be AD squared, which is x, plus CD squared. Okay, it's always the hypotenuse squared equals the other two sides squared. Okay, so that means AC, which is 65, we just worked it out, equals x squared plus 25 squared. So now here we've got a little thing going on. Alright, I don't know what x is, and x is not by itself. It's going to complicate things. So what we're going to do is we're going to move this 25 square there. Plus becomes a minus. The square just goes along for the ride, but because it's being added to the x, the plus becomes a minus. So it's 65 squared minus 25 squared will give us x squared. Whenever you have to work out a side that is not the hypotenuse, you're going to have to subtract. Remember that. Okay, again, I want to get rid of the square, so that will be square root 65 squared minus 25 squared, and that will give us x. So let's do that all at once. X equals 60. Let's see the marks. 60 correct answer only. No, they made it so complicated. You can do it all at once, is what they're saying. Either way, I guess you get a mark for that, getting a mark for some working out, and you get a mark for the answer. Something like that. Okay, question 26. Circle. The moment you see circle, you just go C equals pi d, yeah, or C equals 2 pi r, or A equals pi r squared. Memorize those, yeah, tattoo them. No, don't tattoo them, I think you'll cheat. Write them on your ceiling when you lay in bed all day, it's there, and you read it all the time. Work out the circumference of the circle. It's easy. No, it's not easy. Because we don't know what is the diameter or the radius. We only know what's the area. So let's write that down. We know that area equals pi r squared. Good. You know the area is 25 pi. Now we just need to shuffle some things around. Okay, first thing I'm going to see, this is pi times radius squared. So if we take the pi, we move it to the other side, it becomes divide. Now what is pi divided by pi? You have a pi, you take away pi, and you divide a pi. Just put it pi divided by pi. Anything divided by itself is 1. Okay, and 1 times 25 is 25. So pi divided by 5, can we just cancel that? That gives us 25 equals r squared. Get rid of the square again, move it to the other side, it becomes square root. That means r, the square root of 25 is 5. So we got the radius of the circle. Thank goodness, because now we can use this formula to find the circumference. So we do C equals 2 pi r, C equals 2 pi times 5. What's 2 times 5? It's 10. But if you type it into your calculator like that, of course, what does it give you? 10 pi, because 2 times 10. Do we want this one or this one? Give your answer in terms of pi. That is just 10. That's terms of pi. This is the answer as a number. This is the answer in terms of pi. Okay, so the answer there being 10 pi. There we go, see? Two of these circles is used as the ends of a cylinder. Is this the last question? Yeah, you see. That's what they do, last questions. Always to try and bowl you out of the park. Okay, so let's draw that. Two of these circles is used as the end of a cylinder with height h. Now remember, the total surface area of a cylinder, let's just draw the net. That's the net. So you have to open the cylinder. It's two circles, the height is here. Okay, what do we know? We know that the area is 25 pi of the circle. So that's 25 pi. And that's 25 pi. Okay, so the area of the two circles is 25 pi times 2, or 25 pi plus 25 pi. That's 50 pi. The whole thing is 170 pi, so we subtract those 50 pi. Damn it, man, we need to go to the bakery and eat pies. We subtract that, two circles, we get the curved side of the cylinder, which if you unfold is a rectangle. It's got and serve an area of 120 pi. Good. Okay. Now, the question is, How long is that rectangle? What is this length? If we got that length, we can just say h times whatever that gives us 120 pi. Well, if you fold that rectangle around, it forms the circumference of this circle. So the length of the rectangle, the circumference of the circle is the same. Do we know the circumference of the circle? Yes, we do. We just worked it out over there. So we know that this is 10 pi. So we know if we multiply the length of the rectangle with the height of the circle, we get 120 pi. Now we're just going to move this 10 pi to the other side. The opposite of times is divide. What's 120 pi divided by 10 pi? Well, of course, it's 10. Well, because pi divided by pi is 1. And 120 divided by 10 is 12. If you're not sure, I mean, just hammer it into your calculator. 120 pi divided by 10 pi 12. Are we right? Yes, we're right. Okay, and that's it. It's done. Genius. See you again soon. Keep working hard.